Hello everyone, welcome back to our college algebra course. Today in this video clip I'm gonna go over two sections. Section 3.6, it is about how to solve a word problem. That's pretty much the same. And the next one is gonna be section 4.1. We start chapter 4, talk about linear functions. Now I claim that actually 4.1 is pretty simple because you guys learned it already under chapter 2, so we just kind of review. So the main thing that I'm going to talk about today is 3.6, okay? It's how to solve a word problem, how to create a function out of an equation function out of a word problem. So there's no new material, so all I can do in this section is I give you a bunch of examples, and for each problem I will just show you how I will think of it and how I will tackle the problem to get to the answer. Okay, so let's start with the first one then. They give you, let P be the point on the equation y equal to x squared minus 8. Okay? So what do they give you? This one, as you learned already, is a parabola, right? Parabola y equals x squared minus 8, so it's going to look like this. And P is a point on it. P is a point on that line. So P, I don't know where it is, so it's just P. X comma y. So this is x, and this is y for the point P. And they ask us to find the distance d from P to the origin. Distance from P. The origin means 0, 0. The origin is right here. Okay? So the key thing that we're looking for. So we read the problem. First of all, well, you see the problem, you read the whole thing, and you find the keywords. The keyword for this one is find the distance. Okay, find the distance. The book called distance, denoted by letter D. Distance D from P to the origin. Origin means 0, 0. So you ask yourself, how do I find the distance? Is there any formula that involves distance? And recall that we learned a formula called the distance formula. So I'm trying to write down the formula again for you guys. Distance formulas to tell you. Okay? Distance D can be calculated at what? We have 2 points, say x1, y1, and then x2, y2 that we gave you guys before. The distance between the 2 points is what? x1 minus x2 squared plus y1 minus y2 squared. That was the formula that we have. Okay? So in this particular problem, the point P is xy. We have the point xy. And the second point, the origin is 0, 0. So if you think of x1 is x, and x2 is 0, y1 is y, and y2 is 0. So plug into our formula. This and these going to be x minus 0 squared plus y minus 0 squared, and take square root. Of course, we can simplify as what? Square root of x squared plus y squared. Now let's read more. Express the distance d from P to the origin. That's a function of x. As a function of x. What do we mean by this? So they want to see d can be expressed as everything in terms of x. Another word, they don't want to see any letter y, any other letter rather than x in the formula. That means that we have to convert y back to x. And do we have any way to substitute that y in terms of x? We have the equation right here. Y equals x squared minus 8. And the point P is on the parabola, so y is equal to x squared minus 8. We can replace y by x squared minus 8. So this is x squared plus y. I should not write y again. I have to replace y by x. Y squared now becomes x squared minus 8. Everything squared. Okay? So you answer the question. They ask you to find a distance d as a function of x, and your answer is this. Right here, d is equal to square root of x squared plus x squared minus 8. Everything is squared. You see, d is a distance from the origin to the point P. Let me use a different color. And the distance from here to here, d. Of course, that distance is going to change because the point P is going to change, okay? Whenever you have a point P on the parabola, then you have a distance. New point P is going to give you a new distance. And that distance depends on the value of x. Actually, it depends on x and y. But y is a function of x. So you can substitute y by x squared minus 8. Now everything can be written in terms of x. Another way, whenever you have a value of x, you can plug in the formula, you can find a distance. Okay, that's question A, right? Question B. What is d if x equals to 0? I can erase something. I got a formula ready. When x equals 0, you want to find d, just simply plug in x equal to 0. Okay? So this is the heart of the problem. This is the main point of the problem. They give you a bunch of information, and from a bunch of information, you're going to get to the function or the equation or the formula. That's what you have. And then the rest is just calculation. Okay? When x equals to 0, then d is what? Square root of 0 squared plus 0 squared minus 8, everything squared. Well, 0 squared is 0, and minus 8 is square is 64, so this is square root of 64, and square root of 64 is 8. Okay. When x equals 0, y is going to be right here. This is the point. And that distance is going to be 8. Okay. And next question, what is d when x equal to 1? Well, you do the exact same thing. Just plug in x equal to 1. You got d is equal to square root of 1 square plus 1 square minus 8, everything squared. And then I'll let you calculate this. Okay, this is 7, 49, 50, square root of 50. Okay, I'll let you calculate it. And I claim that all the workaround, really, even though it's going to be different content, but the way we tackle them, the way we solve them is very similar. First, we read the entire problem. We try to find the keyword, the main thing they ask in the problem is like looking for the theme when you read an essay. And then, excuse me, and then you guys look for the formula or the equation that may involve the problem and try to figure out the equation from there. Okay? Let's try another one. Look for another one. I'm just bringing out a list of problems from our textbook and I'm just trying to choose one. Okay, something that's a little bit harder. Okay, number 7. All right, in your textbook, a rectangle has one corner in quadrant number 1. On the graph of y equal to 16 minus x squared. So you see that this one is going to be a parabola upside down. We only talk about quadrant number 1, so we care about the first part, okay? And we have a rectangle like this. I'll show you the picture, all right? This point is x comma y. So this point right here is gonna be x0. This one gonna be y0, right? The origin right here. So they give you a rectangle. In the first quadrant and have one corner on the parabola, and the parabola is y equal to 16 minus x squared. Let's see what they ask us. Express the area of the rectangle. Area of the rectangle. Rectangle as a function of x. Alright, this question, find the area of the rectangle. So the rectangle we're looking for is right here. Of course, this point is moving along the parabola on the first quadrant, okay? This point move up here, you have a new rectangle. Move down here, you got another rectangle. Anyway, the area of rectangle is going to be changing. It depends on the variable x. So we have to find the formula, the equation for the area of the rectangle. So the key words, I have to keep saying it over and over. The key word for this problem is find the area of a rectangle. Then we ask ourselves, do we know any formula for area of rectangle? We know that the area of a rectangle is length times the width. Okay, it's going to be the area of a rectangle. So let's apply to our problem right here. Area, this is the length, and this is the width, the height, same thing, right? So this is x, y. So the areas I'm going to denote it by a letter A. A is equal to length times width is x times y. And that's really the formula for the area of rectangle. But the question requires you more than that. They ask you what? Find the area as a function of x. So everything in the equation, in the formula, is going to be written in terms of x. No y, no z, no other letters allowed in the formula. So I have to substitute that y with something in terms of x. Oh, it's right here. Because that point is on the parabola, so y is equal to 16 minus x squared. So this is x times 16 minus x squared. And you technically just answer the question. The area can be written as, if possible, you can simplify. If you don't, that's fine. Okay, just leave it that way. 16x minus x cubed, because I did a distribution. Otherwise, just leave it here. Right? The area as a function of x. So whenever x moves, x changes, you have a new area. Okay? And then the next question is going to be x going to be equal to something, or what is the domain of x? That's a good question. How do you find a domain? Well, if you have this function right here, the domain could be all real numbers. However, in this particular example, they restrict our movement for x. It's going to be on the first quadrant, all right? So from here to here. So where can x can move? From 0 all the way to this point right here. All right? Can you find this point right here? Yes. That intersection right here is y equal to 0. So we solve for this one for y equals 0. You got 0 equal to 16 minus x squared, or x squared equal to 16. So x equal to 4 or negative 4. We only take the positive one because it's on the first quadrant. Okay? So the domain is all real number x between 0 and 4. At least 0, at most 4. On those 2 points, the area is going to be 0. Okay? X equals 0, x equals to 4, the area is equal to 0. Okay? And another question that requires graphing calculator. They ask you what? Find a point, approximately, right? Of course, at this level. Find the value of x so that you got a maximum area. And let me try to explain the idea of the question. If that point P is so low right here, and your rectangle is going to look like this, and you don't have much of the area. If that point P, X, Y, way up here, then your rectangle is very skinny. You don't have much of the area. So I guess whenever B is somewhere in the middle, like right here, right there, you guys going to have a bigger area. Okay, close to a square, I think it's going to be a bigger area. So how do you find a point X such that you attend a bigger area, the biggest area? And the book, our textbook asks you to use a calculator. So just plug that thing in the calculator and then trace along the graph. And a couple of students ask, I don't know which calculator you have, so I'll just say it in general. If I see this problem, I can even use Google. Just type graph y equal to 16x minus x cubed. And Google will give you a graph and just simply trace along the graph. You'll be able to find the point where you attend the maximum. Okay? All right, let's move on. Try another one. All right, this time I see a square and a circle. This is number 10. Just try another one. Try number 10. I don't know what the problem is about, but at least I see the picture. So let me just put it out, show you guys a picture. I have a square, and I have the circle inscribed the square. All right. A circle of radius r is inscribed in a square. Okay, so this is circle, radius r, and obviously the circle and the square are going to have the same center. Okay. Question number A. Well, that's all about the problem. Question number A. First question. Find the area of the square. A. Find the area of the square as a function of r, as a function of r. Okay. Again, word problem. Look for the keyword. The area of the square. All right. So how do you find the area of the square? This called this side, right? And then square up. I don't know what it is. This is called x. Okay. Area is equal to x squared. I don't know what it is. Okay. But can I stop right here? Answer is no, because they want what? The area as a function of r. You have to express x in terms of r. So have to find x. Okay. X is right here. So a little trick is going to help. If you draw the diameter of the circle. This is R. This is R, and you see what? The diameter of the circle is exactly the same as the side of the square. So really, x is equal to diameter, which is 2r. Okay? Now, I figure out x in terms of r. So this is x squared, which is 2r squared, which is 4r squared. Now I have the area in terms of r. I'm done. Question B, express the perimeter P of the square as a function of r. So question B, instead of area, now we talk about perimeter. P as a function of r. Okay? So you ask yourself, keyword, perimeter. And what is a perimeter? How do I find a perimeter of a square? Perimeter is the total measure, the length of all the four sides of the square. So if this is x, the perimeter is x plus x plus x plus x, 4 of them, right? 1, 2, 3, 4, 4x. So P equal to 4x. And we know that x is 2r because that's a function of r. So 4 times 2r, which is 8r. We done the problem. Ask you to find the perimeter as function of r. You guys see? Word problem seems complicated, looks complicated. But if we read the question carefully, we do step by step. We look for the keywords. What are they asking for? What are they looking for? And we try to link to formulas we know. So area, I look for the area formula. Perimeter, I look for the perimeter formula, and then I will satisfy the requirement that the question asked me. Okay, take time to learn step by step. Okay, try one more. Okay, then I'm going to move on to the next section because I see that this is the second to the last one, very similar. Usually they give the 3 or 4 problems with the same type, and then another 3 or 4 problems with the same type. I just choose one of each type and put on the board. Okay, try another one. This is problem number 11. A wire of 10 meters long is to be cut into 2 pieces. So what I see in the picture is this. They give you a wire, okay, of 10 meters long from here to here. How long is it? 10 meters. So I will draw exactly what the book draws. 10 meters, okay? And they say they're going to cut it up into 2 pieces. They cut right here. Cut into 2 pieces, all right? And the first piece they're going to make a square. So that piece they're going to bend it that way. And the second piece they're going to make a circle. All right? That's what I saw in here. And find the total area. We deal with area again. Total area of the 2 shapes. Of course, total area. That's a function of x. Well, what are you asking here? Oh, I see. So they call that length right here is 4x. And they denote right here is 10 minus 4x. I understand. You see why they call they use this one as 10 minus 4x? If the length of the first piece is 4x, and total length is 10 meters, so you take 10 meters, subtract 4x, you got 10 minus 4x. And then the next question I have is, why did they call it 4x? Because I see that they're going to use the shorter piece right here to make a square. So the perimeter of square is what? 4x, if you didn't know it by x, the size x of x, right? So the perimeter is going to be 4x. And of course, see what? The circumference of the circle is going to be 10 minus 4x, right? Circumference. The length of the second piece right here to make a circle is going to be the circumference of the circle, which is 4x. So I know that the perimeter of the square will be 4x. The circumference of the circle will be 10 minus 4x. That's what I know. And they asked to find what? The total area. That's the key, the total area. So I have to calculate the area of the square I have to calculate the area of the circle, and then I'm going to add them up. I have the total area. So if the side of the square is x, then the area of the square is what? The area of the square is going to be, say, how do you know that way? Okay. A stands for area, and then the little square right here means the area of the square is x squared. Okay? And I have to look for the formula for the area of the circle. So area of the circle is pi r squared. This is r. Okay? So the total area is going to be this area of the square, which is x squared, plus the area of the circle, which is pi r squared. Am I done yet? No, not yet, because they want the total area as a function of x. In other words, they only want to see the letter x on the right-hand side. No other letter allowed. So pi is a constant, 3.14159 is okay. R is not okay. R is another letter, another variable. We have to convert R to x. So how? Oh, this is tricky, huh? What do I know about R? All I know is what? The circumference of the circle is 10 minus 4x is the circumference. And I have to look for the formula for the circumference of the circle. And I think the circumference is 2 pi r is the circumference. Circumference is 10 minus 4x, which is 2 pi times r. Okay? So I can solve r from here. Divided both sides by 2 pi. I got 10 minus 4x equal to 2 pi is equal to r. Bingo. I can simplify this a little. Take away 2 on top and bottom. I got 5 minus 2x equal to pi equal to r, right? Because take away 2 from 10, I got 5. Take away 2 from 4, I got 2. Take away 2 from 2 pi, I only have pi left. So this is x squared plus pi times 5 minus 2x over pi, what? R squared, so squared. You can stop right here, and this is the formula for the area of circle in terms of x. Okay, x squared plus pi. I see that we can simplify more, but let's just stop right here. That's good. Next question: what is the domain? That's a good question. I erased it. So I have to redraw it. From here to here is 4x. From here to here is 10 minus 4x. The domain, right? In other words, what is the maximum of x? What is the minimum of x? Say if you cut right up here, means what? You don't make any square, then x is as small as 0. And if you use the entire rod to make the square, then 4x is maximum of 10. And you cut it right here, then what? You don't have a circle, only have a square. Okay? No, I say it backward. You cut it right here, you don't have a square. You use the entire 10 meters to make a circle. Apologize. If you cut it right here at the end, no cut, really. Then what? You use the entire piece of rod to make the square and no circle. Okay? So you cut up here, x is 0. You cut down here, 4x. The whole thing is equal to 10. The entire perimeter of the circle of the square is 10, so x is 2.5. That's the longest for x. This is the shortest for x. So x is between 0 to 2.5. 0 less than or equal to x less than or equal to 2.5. 10 over 4. That will be your domain. Okay. But you have the function right here. See, mathematically, x could be anything. But in this particular application, apply to the rod, x is somewhere between 0 to 2.5. Okay? And grab the function and find the smallest point. As I say, I would strongly encourage you guys to use Google. Okay? A couple of students has asked me that they don't have calculators, or how we do the problem without a calculator. Just answer it the same way. You can nowadays the internet's everywhere, so just go on the internet, type. You can look for a calculator online, or just simply look in Google. I type graph x squared plus this one pi times parenthesis 5 minus 2x over pi close parenthesis raised to the power of 2, and you hit enter. Then internet we're going to give you a graph. Okay, I think I tried it already in Google. You have a graph, and then you can find the maximum or minimum points on the graph, which is going to answer the question. And if you want to have more accuracy, just simply zoom in or zoom out or zoom in. Gonna give you more decimal. Okay? And that will be the last problem on my piece of paper right here. They have like 12 problems total. Every 4 problem they change the type, so I give you all samples of those exercises that I have. So let's move on to the next section, and I'm glad that this section is not going to be hard at all for you guys. So let's make it quick. Just a good chance to recall about the linear function.